escaping gas would nudge the comet in a new direction, away from the Earth. But Campbell believes the laser has advantages. Unlike the solar mirror, lasers are known and trusted technology. And while the power of the solar mirror is dependent upon its proximity to the Sun, a laser could be powered by a small nuclear reactor and be just as effective in deep space.
Aaron, this is an actual fragment from a meteoroid.
We can't put the lasers on Earth because the atmosphere scatters laser beams. Campbell believes, to guard against a short warning comet or asteroid, our only hope is to place our laser defense in a roving interceptor or at a permanent base on the Moon.
Clearly, putting such a facility on the Moon would be a tremendously expensive project. At the present time, since we don't know of any object that's coming in to strike us, it'd be more like buying a very expensive insurance policy.
But it is possible one could show up tomorrow. And if it did, we may have the means to prevent catastrophe.
It's red hot, so be very careful.
I was surprised that we were as effective as we were with such a short radiation time by the laser. And certainly we expected a little more resistance from the meteoroid fragment, but still the laser very easily melted it and went through it.
But if a killer comet appears before any of these plans are ready, what will we do? Our only option might be to try using nuclear weapons after all. In fact, NASA has proposed a rocket that would provide a series of standoff explosions. Unlike the usual movie scenario, these would occur near the asteroid, not on it. Their aim being to alter its course fast. No one wants to use nuclear weapons in space, but they might be able to preserve us from extinction. In the past, asteroids and comets probably wiped out many species, even paving the way for mammals and human beings to emerge. But now it seems it may be possible for us to avoid extinction.
We can make this not happen. And it's a testament to the power of human technology and imagination. We can take this terrible disaster and we can cause it to not occur.
But what about events closer to home? Every year, hurricanes take lives and destroy homes and businesses. Today, there is no way to prevent or alter the path of a hurricane.
If you've lived in New Orleans in 2005, you have never experienced a major hurricane. You didn't. Hurricane Katrina was a Category 3.
Hurricanes fueled by warm ocean waters have always brought devastation. With rising ocean temperatures brought on by global warming, the future may be even worse. With more Category 4 and 5 hurricanes.
What I'm about to describe is entirely hypothetical. Imagine, if you will, a very intense hurricane like Isabel, Hugo, for example. Continually deepening, intensifying, slams into New York City just inland from the Hudson River. All of the evacuation routes, the subways have been completely flooded and overtopped by flooding water. A storm surge of 15 to 20 feet slams into the beaches of Long Island. Many homes are destroyed, swept inland 3 to 5 miles, nothing left. And if people have not been evacuated from Long Island to New York City, they will have drowned.
Storm surge damage would be so prevalent that Manhattan would be underwater for days at a time. The wind energy from the hurricanes, the windows would be blown out. A lot of these buildings would be blowing over. Evacuating the city would be nearly impossible. It would be a disaster.
A major hurricane can spread to as much as 800 kilometers across, with winds topping 240 kilometers per hour. Over a 5-day span, they thrash and drive the energy of 250,000 Hiroshima atomic bombs. Can human beings ever hope to defuse these killers?
We are above most of the clouds now.
Joe Golden has spent his career believing that it's possible.
Hurricanes are really an amazing, incredible heat engine. We want to be able to weaken a hurricane. You somehow have to impact or decrease the heat uptake into the storm, or you have to somehow modify the precipitation processes that are occurring in the hurricane.
It's been tried before. The United States government funded the effort. Started in 1962, Project Stormfury was an ambitious program that tried to choke the hurricane's heat engine. Aircraft flew directly into hurricane clouds with an ingenious plan to use the hurricane's own source of power, heat, to destroy it from within. They dumped silver iodides in rain bands just outside the eye wall to react with supercooled water, water moving too fast to freeze. The collision of the chemical and the supercooled water creates ice crystals, and the reaction gives off heat. The heat would cause a new, much wider eye wall to form, robbing the storm center of its fuel and its fury. But in 1983, after years of controversy and tens of millions of dollars, the project was shut down, without proof they had ever been successful. Years later, new flight data controversially suggested there was ice, not supercooled water in the clouds, so the seeding had been useless.
And now we're coming up to some taller clouds just off the left wing here.
Joe Golden began his career as a graduate student with Project Stormfury, and he's never given up the hunt for a successful hurricane killer.
There are good friends of mine feel that after the controversy surrounding Project Stormfury, that scientists should not be messing with Mother Nature. I respectfully disagree. I think as a scientist, we owe it to the American public to give it our best shot.
Golden remains an outspoken advocate of cloud seeding. Today he's visiting Calgary in Canada, where a cloud seeding project works, turning hailstorms into harmless rain.
We're going to commence seeding at this time.
Because these cloud storms do contain supercooled water, the millions of silver iodide crystals interact with them to make ice crystals. The ice steals moisture from the air, preventing the hailstones from growing larger. And the result is a harmless rain of tiny pellets.
Over the last few years, the Alberta Hail Project has produced very positive results in protecting those cities from big hailstorm damage.
Witnessing this is rewarding, but Golden's task is even greater. He's convinced that new research has unlocked the mystery of how to kill a hurricane. Golden believes answers can be found in the dust storms of the Sahara. Satellite tracking shows that when the drifting dust particles collide with developing hurricanes moving off the west coast of Africa, the hurricanes weaken, sometimes dramatically. So how does nature succeed where Project Stormfury could not? New research suggests the airborne sand particles cause lots of small raindrops to form. Millions of these tiny raindrops evaporate as they fall, cooling everything around them and robbing the hurricane of its source of heat. Golden believes he's found a way to mimic the actions of the wind-blown Sahara dust by using salt ground to a microscopic size. There is plenty of testing to be done, but Golden has a vision of the future that looks a lot like stormfury.
You need large aircraft. Large aircraft that could carry, let's say, 1 to 2 tons of seeding material for each aircraft. So these aircraft would be deployed 150 to 200 miles away outside the hurricane eye.
Each plane would carry up to 2 tons of salt. Golden believes that the seeding methods could reduce hurricane winds by as much as 10 or 15%, enough to reduce storm damage costs by tens of millions of dollars and save lives. Golden has never wavered in his belief that a hurricane can be modified from the air. But an even more ambitious scheme aims to alter the ocean's surface itself. Alan Blumberg is a professor of ocean engineering at Stevens Institute of Technology in New Jersey.
All the energy from a hurricane comes from warm water at the surface. So it's obvious to any oceanographer that the water controls what's going on in the atmosphere.
Blumberg's idea is to deprive the gathering storm of fuel by replacing the warm water at the ocean's surface with the colder water that lies beneath.
Now, how in the middle of the ocean would you bring cold water to the surface? There's no electricity in the middle of the ocean. One concept is to use a pump, a tube, that is powered by waves at the surface.
Blumberg's pump is a one-way street. Cold water is allowed to enter at the bottom and exit at the top. It would be powered entirely by the ocean's natural wave action.
You can show this easily with a straw, with a drink, by putting your finger over the straw, and you lift it up and water will come out. So to build on that concept, we designed a prototype. Okay.
To test the water flow, Blumberg injects dye into a small-scale prototype.
That stuff is really yucky, isn't it?
He will know his test is a success if the dye appears at the top of the pool.
Will it work in the real world? Well, if it doesn't work here in this tank, it's never working anywhere else. Look, see? Tremendous. That's exactly how it's supposed to work. Exactly, just like that. Couldn't be better.
Scaling up from the wave pool to the ocean is a huge leap. Each pump would be 1 meter wide and 300 meters deep. Blumberg is undaunted.
If you design a pump simply, and this is the simplest kind of design, the waves will not knock it over. As long as you have a secure float at the top and a weight at the bottom, the pump very quickly rights itself. So the bigger the wave, the more energy is there available to bring cold water up. So I say bring on the big waves. Let it happen.
Like Joe Golden's cloud seeding system, Blumberg's plan calls for a squadron of transport planes stationed around the southeast of the United States, each one carrying a set of rolled-up 300-meter-long pumps. The pumps would be dropped on location and cool the water down